Class, what is fragmentation?
It's when data breaks into pieces.
Exactly. Watch this. And the opposite?
Defragmentation. It puts the pieces back together.
Today we're going to learn defragmentation.
But why are we learning this? This doesn't belong to computer subject.
Yes, it belongs to computers, and today we'll learn how. Is anybody here who bought a new PC within the last 2 years?
Yes, I have.
How was the response of the computer?
It was very fast.
But when the same PC grows old and gets filled with data?
It starts slowing down. As the storage fills up, the computer has to work harder to find and access files, which causes the lag.
What do you do in this situation?
I clear temp files, prefetch files, run scan check, and reboot.
Does this solve your problem?
Sometimes, but only temporarily.
I see. So what next did you do?
I went to the IT technician. He recommended some upgrades.
Okay, and what are those?
He asked about my RAM and suggested increasing it.
Later, he asked about the disk, and I answered that I'm having hard drive. So he recommended to upgrade it to SSD.
Okay, is there anything else he asked or recommended?
Yes, he asked about processor generation and then operating system.
So I said Windows I'm using. So he suggested after this, all issue that doesn't resolve, switch to Linux.
Oh, okay.
But Linux is tough to operate if you're not from a technical background.
That's a good point.
Yes, I'm worried.
Does anybody know why the technician asked so many questions? There's a key troubleshoot that could save money instead of hardware upgrades.
Is it? We don't know how.
That's what we're going to understand today.
So first we have to understand why this slowness comes after a few months or a year. There are few key reasons for which you go with above pattern, which your technician has walked you through.
Okay, sir, then will you explain us the reason?
Certainly.
Now tell me, when we talk about performance in computing, what are the primary components that come to mind?
Processor, memory, storage, network connectivity, and operating system.
Excellent. Now look at the workflow. Whenever you try to start an application, what exactly happens in the back end? Once you click the application, the operating system receives the request and asks the file system where the application's executable file is stored. The file system checks its metadata and identifies the exact location of the application on the storage disk. The operating system then instructs the storage device to read that executable file. The data is transferred from storage into RAM because applications cannot execute directly from storage. Once the required data is available in RAM, the processor starts executing the instructions and the application opens in front of you. Now, if we observe this workflow carefully, 3 major components are involved: processor, memory, and storage. And each one has saved certain information while processing. Does anyone know where it has saved that all information?
In its cache?
Correct. Now, the question is, if we close that application and reopen it, will the same workflow will be followed or not?
Yes.
It will not follow the same process because it has already saved similar instructions in its cache memory. So once we give a similar command to the same application, the processor will check its cache first. It will not initiate a new process, but instead use the already saved data. It directly goes to RAM, and the same with RAM and storage disk. Now, what exactly you guys observed in this all? These all components have skipped many area of their process and directly goes to the output. Correct.
And the reason is very fast than the time it has taken at the very first time. After this, there is challenge. What's now? The challenge is, these components, especially CPU and RAM, has their own limited space for cache. So once this cache gets full, what will happen with the next new process?
It will initiate each and every process from scratch, and it will not save any information due to no space in its cache, and this will make the response of processor and RAM very slow. Now, come to your actual scenario where your technician suggested something.
But what does workflow have to do with those suggestions?
We come to know the 2 reasons of slowness, which are once your CPU or RAM cache memory gets full. So now, how are you going to make space here?
You must have to reboot the system cause both are having volatile memories. So once you reboot the system, it will flush all data within it. So this is how your rebooting the system works for the slowness.
Or you have to upgrade to the newest generation of CPU or increase the size of RAM so you can get more cache space. Now the next is storage. This is the most underrated component for the performance.
How is that?
Because your all data stores here only. So if your hard drive didn't respond to you quickly, everything will be slows down. Look at your application. RAM has loaded that from storage only. So here, does every time the hard drive will look for the application in its space when RAM will ask for the data?
No, because it will also has its cache.
Correct. And these are your temp and prefetch files.
So every time before approaching the hard drive to look into space, it first goes these 2 locations.
So once the number of files increases, RAM takes more time, locate the required application to load. And once you delete these files, you start experiencing quick response again.
Now coming to your third troubleshoot, that is scan check. This comes in frame when you have certain corrupt files or blocks in your disks.
How come this impacts?
Corrupted blocks slow down performance and cause system instability.
Whenever unexpected shutdown happens while writing data, you know what happens? The data become unreadable. And your file system stops proceeding further and tries to find new blocks to store the next data.
So scan check removes these blocks and makes space for the file system. Now we come to know the reason behind all troubleshooting, and if it's still not resolving the issue, then we go to upgrades of components. correct? But what if I say still one troubleshoot or reason is missing?
That operating system part?
No, that's not. Because what if your application is not compatible with Linux OS? So I will explain this as well in some time. So when you store data into your disk, how fast data is written?
Depends which disk we're using.
Exactly.
We'll consider hard drive and SSD, so these two types where
One runs on magnetic mechanism, which is your hard drive, and second runs on electronic mechanism, which is your SSD or NVMe.
So the SSD is faster?
Exactly. So if you see the architect or mechanism of hard drive, it has actuator, where the header is located in lock position, then comes the platter, which actually rotates. And the speed of its rotation decides the speed of hard drive. So if we hear someone says my disk has 15K RPM or 10K RPM,
it means the platter rotating on that speed.
so whenever you write or fetch data, the platter has to move, then the header will act to write the data. But on the other hand, SSD or NVMe works differently. They use electronic mechanisms and have no moving parts. So it stores in cells using electrons. By trapping or releasing these electrons within transistor gates, it represents the data. It runs on the NAND and flash algorithm. NAND stands for not and in Boolean terms.
What is the case of operating system?
Now comes your operating system. So whenever you write data, we know the operating system never interacts directly with hardware, so here also the same scenario.
Does it have firmware?
No. It has one program called file system. Each operating system has its own file system, which helps to read or write data into your disks. So in Windows, it is NTFS, and in Linux, it is ext4. So NTFS writes in format like it scans for first empty block and writes randomly in continuity so there is no boundaries. And on other side, ext4 writes like first available block, then it will leave one block empty, go to third, and will write. This is how it writes, and the reason it automatically creates the boundaries between two types of data. Now in disk, when we start writing data using NTFS, it writes in an unorganized and scattered way. And as there is no boundaries between the data, every time when we fetch it, file system has to validate the end of each data.
And this type of scattering the data in an unorganized way, called as fragmentation.
This is how we actually observe the slowness, and this is the reason even after rebooting the system, the slowness never goes away.
That is why I was experiencing slowness every other day.
Now, what is the resolution for this? We call it defragmentation. This we experience mostly in Windows operating system due to the behavior of its file system.
So in Linux, we don't observe this?
No, we observe it there too, but when the drive gets near to full, as there is no more space left to leave empty block. So we'll have to follow a few steps to resolve this.
Click on Windows icon and type defragmentation in search bar. Now open it as admin. New window will appear. Here you will see list of drives, disk type, and fragmentation %. Just below, you will see the change setting option. Here you can schedule your optimization, and even you can choose specific drives too. Now you have to choose the drive where you want to run defragmentation, and click on optimize. Now it will take some time basis on drive size and the fragmented %.
Yes, it's quite easy.
So this is all for today. I hope you all have enjoyed the lecture. Please don't forget to like and share with your friends. If you have any query, please note in comment section. And do subscribe to channel as it will motivate me to create lecture on other topics. Thanks for tuning in.